So we're going to discuss completing the square for quadratic equations. This is part 2. So please watch part 1 before watching this because it does get a bit complicated. So this is another video from gcsemathsexpert.com. Okay, so we're going to discuss the meaning of completed square form, and then we're going to solve quadratic equations. Okay, if we consider the quadratic equation x squared minus 6x plus 9, and its completed square form is x minus 3 all squared. Now y is equal to x squared minus 6x plus 9. From this we can see that in front of the x squared there is a plus 1 term. Yeah, it's a positive 1 term, it's positive. Therefore, these 3 dots mean therefore this curve is a trough type. Yeah, it has a minimum, a lowest point. Yeah, here. Okay, this is the minimum point. Now again, the same quadratic can be written in its completed form, and it's this x minus 3 all squared from here. Yeah, CSQ completed square form. We can say that at the minimum y for this curve is 0. It's touching the x-axis. Yeah, when y is equal to 0, x is equal to plus 3. Now how do we get that? Well, we can use the completed square form to find the minimum point. For example, if I put x as plus 3 here, plus 3 minus 3 becomes nothing. Yeah, and nothing squared is nothing. Yeah, so y is 0. So that's the minimum point. So at the minimum point x is 3 here, and y in that case plus 3 minus 3 is 0, so y will be 0. So that's the lowest point, and the completed square form gives the coordinates of the minimum, the lowest point. In this case it's 3 0 3 0. Okay, another fact is that, so this is 1 point. Another fact is that the intercept on the y-axis, which is in this case it's 0 9. So this is where the graph cuts the y-axis. In that case x will be 0. Yeah, so if we put x is 0, minus 3 times minus 3, that's what we will be left with is 9. Yeah, but also see this quadratic equation in this form, this plus 9, this constant. Yeah, this tells us the y-intercept. That's when the curve cuts the y-axis. In that case x is 0 and y is 9. Yeah, so you could just take it from here. This plus 9 is telling me that's the y-intercept. So you can get it from the original form, it gives the y-intercept. Now the general shape of the curve is like a U shape. Yeah, like this U shape. Yeah, right, it's symmetrical. That is, this minimum point, if you put a mirror here, this will reflect here. So if you have one point here, that's the minimum, and if we have another point, that's the y-intercept. We could join these, we could draw this, then we can get the other half of the curve by just imagining, there to be a mirror in the center, and you just connect this to this. Yeah, so initially you join these 2 points and you make a curve. Then on the other side, because this is a U-shape, curve, it has a trough and it's a minimum, you just draw the opposite on the other side like this. So this is the minimum point, this is the y-intercept, and this is where it cuts the x-axis. Again, we have another quadratic, x squared minus 2x plus 6, and in its completed square form it's this x minus 1 all squared plus 5. Now y is equal to x squared minus 2x plus 6, because this is x and y relationship. Yeah, now in front of the x squared there's a 1, there's a positive 1. Yeah, it's positive, therefore it's a trough type curve like this, it has a minimum, yeah. It's trough type, it has a minimum point, yeah. And we can find the coordinates of the minimum by inspecting the curve when it's written in the completed square form like this. At the minimum, yeah, the whole of this part of the quadratic will be nothing, will be 0, we'll be just left with +5. But when does that happen? That happens when x, yeah, this x is equal to +1. +1 minus 1 is nothing, so we'll be just left with +5. So the minimum point we could find from looking at this is +1, y is 5, yeah. It's +1, x is 1, y is 5, yeah. Okay, so the minimum point is 1, 5. X is equal to 1, y is equal to 5. That's the lowest point. And the completed square form gives us the coordinates of the minimum, the lowest point. That's why it's so useful. And the intercept on the y-axis is found by looking at this +6, this red 6, this constant. That tells us where the graph cuts the y-axis. When that happens, x is 0, so the coordinates can be 0, 6, yeah, 0, 6 here. So we have this point and we have this point. The original form, this, gives us the y-intercept. Now the general shape is a U-shaped again, because it's positive, yeah, this positive, it's positive here, positive here. It's symmetrical. That means if you put a mirror through the center, it'll reflect on the right hand side, yeah. This has no solutions. That means this curve, it does not cross the x-axis. If the graph has no solutions, the curve doesn't cross the x-axis. Now if we consider this curve, this quadratic, which is -x squared minus 2x plus 9, this written in completed form is this, in completed square form. There's a minus in front of the bracket. Okay, again we have a -1 in front of the x squared, -1. So this time it's negative. It's different from before. It's previously it was positive. Therefore, this symbol means therefore this is a peak. It's like this, yeah. It has a maximum point, yeah, like this, yeah. It has a maximum point. And how do you find the coordinates of the maximum point? Well, you look at the completed square form, which is this, which is x plus 1 all squared plus 10, yeah. Now this will be a maximum when the whole of this left is nothing, it's 0. That will be when x is -1. If you put -1 in here, -1 plus 1 is nothing, the whole of this is nothing, okay, then that will be we'll be left with +10, yeah. So when x is -1, y is 10. That's the maximum point. -1, 10, yeah. So it's maximum 1 plus 10. That's the highest point. And the completed square form gives the coordinates of the maximum, the highest point. If you, if you put -1 in here, -1 plus 1 is nothing. The whole of this will be nothing, and so the max and we'll be left with 10. So that's the coordinates of the maximum point. It's this, yeah, okay. Now again, the intercept on the y-axis can be looking at the original form of the equation, which is this. Is actually 9. Yeah, so x is equal to 9. Yeah, it's this point, and y is x is equal to 0, and y is equal to +9. It's this point. So the original form gives the y-intercept this. Yeah. Now the general shape of this curve is like an N-shaped. Yeah. It's like this, because this is negative. There's a negative in front of the x squared. Yeah. So it's opposite. It's like this because there's a negative in front of it. And again, it's symmetrical. That means if you draw the line through the center, this left, and you put a mirror here, this side would reflect on the right hand side. So if you've got this point, the intercept, the y-intercept, and if you've got the maximum, you draw these two join these 2 points, and you can draw a curve here. Then you know on the other side it will be the same symmetrical, so you just draw a curve from here going down here. So that's how you get the curve. This curve is different to the previous two in that it has solutions, because as you can see, it crosses the x-axis here once and here once. It cuts it once, twice. Now, so this is the equation, this is the quadratic in its completed form. There's a negative in front of it. So what we do is we put the completed square form equal to 0. This is the completed square form, we'll put it equal to 0. Okay, then what we do here, this negative, we have to deal with this. What we do, we take the whole bracket on the left hand side. When you change the side, you change the sign. So this becomes plus here, yeah, from a minus to a plus because you've changed the sign. So we have x plus 1 all squared is equal to 10. Then what you do, you take the square root of both left and right. So this will become x plus 1, and this will become the square root of the plus or minus the square root of 10. Then what you do, you add minus 1 to both left and right. Then on the left will be just left with x, because the minus and the plus 1 will cancel. On the right you'll have minus 1 plus or minus the square root of 10. So these are the two solutions, yeah. So then you'll have x, one solution will be minus plus the square root of 10, which is, and the square root of 10 is plus 3.16. So the answer is, one answer is 2.16, and the other solution is minus 1 minus the square root of 10. So it'll be minus 1 minus 3.16. This is the square root of 10, yeah. So the other solution will be minus 4.16. So this has two solutions. One is 2.16 here. This is where it cuts the curve. So the coordinates are 2.16 x and y is 0. This is one solution. The other solution is minus 4.16. It's here. X is minus 4.16 as y is 0. So since it cuts the x-axis twice, it has two solutions. One here and one here. And these are the coordinates. The coordinates of this is 2.160 and here is minus 4.160. So now we're going to solve quadratic equations. We're going to solve them by completing the square. Okay, so we have this quadratic number 1, x squared plus 4x minus 3 is equal to 0. This in its, so we're going to complete the square for this, and we've done this in the video 1 on this, the video before this, and I've explained it extensively. So now I'm going to do a shorter, more faster way, because I assume you know how to complete the square. So basically you open up a bracket, you put x, plus you take half the coefficient of 4, which is 2, and you square it, and you get this, yeah. And this will be x. We know we'll have x squared. We know the x will be 2 times this. It will be 2 plus 2, which is going to be 4x, and the number term is going to be 2 times 2, 2 times 2, which is going to be 4. Then we say we have x squared, which is the same. We have 4x, which is the same, but we have plus 4 here, minus 3 here. So we have to get this plus 4 to minus 3. So what we say is we have plus 4, we want minus 3. So what we do, we need to add minus 7. Plus 4 minus 7 gives me minus 3. This is what we want. So we put this here, and the whole of this is this. So we put this here, yeah. Then we added minus 7. So this quadratic in its completed form is this. Okay, so how do we get this? I'll summarize again. So from here we have this here. So to this we have to add minus 7. Plus 4 minus 7 gives me minus 3, yeah. Now the whole of this is this. So instead of writing this, we just write this here, and we get left with the minus 7. So we take the minus 7. So this is in the completed square form. Then so this quadratic is in its completed form like this, x plus 2 all squared minus 7, yeah. Then the most important thing, we say we put in the completed square form, yeah. we put it equal to 0. There's a completed square form, you put it equal to 0, put completed square form equal to 0, then we solve it. Yeah, we look at this equation. Well, we can add plus 7 to both sides, then we'll get x plus 2 all squared and 7 on the right hand side. Then we square root the left and the right, then we'll get x plus 2 equal to plus or minus the square root of 7. So x will be, then what, so we have this, then what we do here, we add a minus 2 to the left and right. Adding minus 2 will give me x is equal to, the minus 2 and the plus 2 will cancel out, then we'll have x is equal to minus 2 plus or minus the square root of 7. We add minus 2 to both sides. Now note that the square root of 7, for example, is equal to the positive square root of 7 or the negative square root of 7, because plus square root of 7 times the plus square root of 7 is 7. Also, the negative square root of 7 times the negative square root of 7 is 7. That's why we write plus or minus the square root of 7. This, when we get the square root of 7, it's plus or minus. Okay, so then x will be minus plus or minus the square root of 7. So x will be minus plus the square root of 7, or x will be minus 2 plus the square root of 7, or minus 2 minus the square root of 7. Minus 2 plus the square root of 7, and use a calculator for this, is 2.65. so that's one answer, which is this 0.646 is plus the square root of 7, or x will be minus 2 minus the square root of 7, yeah, which is this minus 2.65, or x will be minus 4.65. These are both the three significant figures. Yeah, so to get the two solutions, yeah, you do one for the positive square root of 7, which is plus 2.6, giving me this, and the other is minus the square root, minus 2.6 of the square root of 7, give me this minus 4.65. So it has two solutions because it cuts the x-axis twice. The quadratic does. This quadratic. So again, we're going to solve by completing the square. So we have this quadratic, x squared minus 2x plus 6 is equal to 0. Okay, so we have to put this in completed square form first. That's the first stage. But previously I've said we've done a long video on completing the square, so again I'm going to do this quickly. So basically you open up a bracket, you put x, you put the half, the coefficient of x, which is 1, close bracket, all squared. If you multiply this out, you'll get this, which you'll get x squared plus 2 times the coefficient of x will be 2 times this, minus 2x, and this number term will be minus 1 times minus 1, which is plus 1. Again, we have plus 1 here, so this x squared is okay, minus 2x is okay. We previously had plus 6, now we have plus 1, so we have to add plus 5 to get to plus 6. Okay, so we take this over here, so this will be x squared minus 2x plus 1, yeah, and to get equal to this, remember we have to add 5 plus 5, so we have this. Okay, now we put in the final stages. The whole of this x squared minus 2x plus 1 is actually this, yeah. So instead of writing all these 1, 2, 3 terms, 1, 2, 3 terms, we write the brackets, yeah, which is x minus 2 close bracket all squared, and this 5 we just carry plus 5, yeah. So that's the completed square form, and we've put the completed square form, remember, equal to 0. Okay, so then we solve this equation, then we add minus 5 to both left and right, and we get this. We have x minus 5 all squared minus 5. Now then the next stage we're going to attempt to square root it, but we have a problem. You can't get a square root of a negative number. It's minus 5. So this quadratic has no solutions. It has no solutions. It does not cut the x-axis. So again, because this is a plus, so it's of the trough form, and But this is the completed square form. We can work out the minimum point. It will happen when x is equal to plus 1. This will happen when the whole of this will be nothing. This will be nothing because 1 minus 1 is nothing, so we just have plus 5. So we have 1, x is 1, and the maximum is 5. This is the minimum point. You can see this is the x coordinate. It doesn't touch the x-axis, it's above it. So the solutions of a quadratic are the point where it cuts the x-axis. This quadratic does not cross the x-axis. Look, it's above the x-axis. Its minimum, its lowest point is x is 1, y is 5. It's 5. So the lowest it gets is 5. Y is 5, yeah? It has no solutions. The coordinates of the minimum, the lowest point, are 1, 5. Okay, so this doesn't cross the x-axis. It has no solutions. So we've been asked to solve by completing the square this quadratic. We've got x squared plus 3x minus 1 is equal to 0. Okay, so again we complete the square and it's this. So it's x plus 3 over 2, 3 over 2 because we can take the half of the coefficient of 3, which is 3 over 2 all squared. Yeah, this will be x squared twice, 2 times this will be 1.5 plus 1.5, which is 3x, and 1.5, 3 over 2 squared is 2.25. So previously, so we want minus 1, yeah? So we want minus 1, but we've got 2.5. So what do? We add minus 2.25 to both, and so the number that you add is minus 3.25. Yeah, in order to balance it, to get minus 1, yeah? So you put this minus 3.25 here, and you carry this blue equation down here. So then this will be equivalent to this, the original quadratic, yeah? Now, this x squared plus 3x plus 2.25 is this, and that is equal to this, yeah? It's x plus 1.5 all squared, yeah? X plus 1.5 all squared. And this minus 3.25 you just carry here, okay? So that is the completed square form. So then you put the completed square form equal to 0, yeah? You put the completed square form equal to 0, okay? Put the completed square form equal to 0. So we have then this equation and we solve it. What we do, we add a plus 3.25 to both left and right. When you do that, this will cancel out, and then you get this. You'll have x plus 5 all squared is equal to 3.25, yeah? Then you square root left and right, and you get this. X plus 1.5 is equal to 1.5, the square root of plus or minus the square root of 3.25, yeah? You carry this here. Then what you do, you add minus 1.5 to both left and right. This will give you x on its own, which is minus 1.5 plus or minus the square root of 3.25. You get a calculator to get the square root of 3.25, which is 1.8. So this one solution will be, so it's will be minus 1.5 minus 1.8, so it'll be minus 3.3. The other solution will be minus 1.5 plus 1 plus 1.8, it'll be 0.3. So these are the two solutions. So this is the last one, and this is a tricky one. So now, we're going to solve by completing the square. So we've got 2x squared minus 6x plus 1 is equal to 0. So with the problem we have here is that we have a 2 in front of this x squared. So we have to get rid of it. We have to factorize it out, factorize the 2 out. So you take the 2 out here and you divide everything inside by 2, yeah? So this will become x squared, this will become minus 3x, this will become half, yeah? So which will be this. Then you complete the square for this. Now you can check if it's correct by multiplying this 2 into the bracket. and this we have to complete the square form. Yeah, so again you put 2 and it's x minus half the coefficient of 3, which is 1.5 all squared, and this gives me this. So we'll have x squared term, 2 times this is minus 3x, and 1.5 times 1.5 is 2.25. Again, so x squared is the same. We have minus 3x, same, but we have plus 2.25. We want 0.5. So again, you say y plus, what do we have to add to 2.25 to get 0.5? So we add minus 2.25, yeah? So y is equal to minus 1.75, yeah? So what you do, you add minus 2.25. This makes y the subject, yeah? So the 2.25 and the minus 2.25, that cancel out, yeah? Okay, then we have the original equation, and we've got the completed square form as well. So we have 2 into this, x squared minus 3x plus 2.25, x minus 6 plus 2.25, and we have this minus 1.75. This is the adjusting number which we have to add to get it to 0.5, yeah? Plus 2.25 minus 1.75 gives me 0.5, yeah? Okay, then what we do, we put this equal to 0, but before we do that, we put another bracket in, yeah? So I'm going to put another bracket in, this blue one, yeah, before this 2, and another bracket after the 1.75. Then this is this, yeah, and that is this, yeah, x minus 1.5 all squared. So we put that in the bracket itself, x minus 1.5 all squared, yeah, minus 1.75, close bracket. And this 2 is outside, so this 2 is multiplying this x minus 1.5 all squared, and this 2 times minus 1.75. Okay, so we put the whole thing equal, we put it in complete square form, and we put this form equal to 0. Now this times this is this, 2 times this is minus 1.52, and this times this is minus, it's going to be minus 2 times 1.75. So what we do, we add plus 2 times 1.75 to the left and the right. So that will cancel the left here. You'll just be left with this 2 times x minus 1.5 all squared, and on the right you'll have plus 2 times 1.75. So we take this down to here, then we divide 2 by both sides and cancel them, so we get left with this x minus 1.5 all squared is equal to 1.75. Then what you do, you square root both left and right. You're left with this x minus 1.45 plus or minus the square root of 1.75. Okay, then what you do, you add plus 1.5 to both sides, yeah? You get this, so you'll be left with x, yeah? X then will be 1.5 plus or minus the square root of 1.75. Okay? So then we'll have x is equal to 1.5 plus or minus the square root of 1.75, yeah? Then we use a calculator to find the square root of 1.75. And so the two solutions are 1.5 plus or minus 1.32. That's a square root of 1.75. Use a calculator, yeah? So the two solutions will be 1.5 plus 1.32, which will be 2.82. That's one solution. Other solution will be 1.5 minus 1.32, so it will be 0.18. So the answer is given to do this 2 decimal places, 1, 2, 1, 2.